Welcome to Bachchi's classes. Today's topic is about angle of deviation delta. What is this angle of deviation? Angle of deviation is nothing but angle between the initial direction of incident ray and the final direction of reflected ray. So, angle between the initial direction of incident ray and the final direction of reflected ray. This angle is called the angle of deviation indicated by delta. Let us understand more clearly. M dash is the plane mirror. Suppose this is incident ray IR. If the mirror is not placed here, the incident ray will approach in this direction directly. This is the direction. But due to the placement of mirror M dash, mirror reflects this incident ray in this way. So actually the incident ray which has to go in this direction has took a deviation. This deviation has taken place due to the mirror. So this deviation is called the angle of deviation delta. Okay, this is the angle of deviation. Then how to find the angle of deviation? Angle of deviation can be found in two ways, clockwise and anti-clockwise. Let us understand. This is, we are measuring, this angle is anti-clockwise measurement. So angle of deviation in anti-clockwise, first let us measure. Anti-clockwise direction. Let the angle of deviation in anti-clockwise direction be delta 1. Let us think that it is delta 1. Then delta 1 is equal to, this is normal, you see. Normal, incident ray, reflected ray RR. Now, this angle is angle I, angle R. We know from the laws of reflection, angle I is equal to angle R. These two angles are same. So, angle of deviation, suppose you see IR, this you mark a letter AB, incident ray, extended ray is AB. What is this? This point of incidence is O. Then what is angle AOB? Angle AOB is equal to 180 degrees. We know that this is straight angle. So what is this angle of deviation? So total 180 minus angle I plus angle R we have to subtract. So delta 1, that is angle of deviation in anti-clockwise direction, is equal to delta 1 is nothing but 180 minus of angle I plus angle R. This is the value. Then we can write this as angle I is equal to angle R from laws of reflection. we can write delta 1 is nothing but 180 minus 2 into angle I, because angle I is equal to angle R. This is number 1. Okay? Here up to here, you note quickly. Pause the video and note. Now, let us understand the angle of deviation in clockwise direction. Clockwise direction. Let it be delta 2. So delta 2 how to find? Delta 2 is nothing but clockwise direction means this is incident ray. This is initial direction of the incident ray A, O, B, and this is the final direction of the reflected ray O, C. So to find this deviation, we have to find this angle. So what is this? This is nothing but total angle is 360 degrees. From this total we have to subtract this part. This part is nothing but, already we deviated, it is delta 1. So 360 minus delta 1. So delta 2 is equal to 360 minus delta 1. Then what is this? 360 minus, what is delta 1? Already we derived in equation 1. That is nothing but 180 minus 2i. Substitute the value. So as a result we will get 360 minus 180 plus 2i. So 360 minus 180, 180 plus 2i. This is number 2. So angle of deviation in anti-clockwise direction, anti-clockwise direction, angle of deviation is delta 1 is equal to 180 minus 2i. This is number 1. Angle of deviation in clockwise direction is delta 2. Delta 2 is equal to 180 plus 2i. Welcome to Bunch's classes. So let us talk more about this angle of deviation delta. Delta, that is angle of deviation, is maximum when angle of incidence I is equal to 0 degrees. How it is, let us see. This is mirror M dash. This is normal. When angle of incidence is at 0 degrees to the normal, then angle I is equal to 0, then delta is equal to how much? Reflected ray will be like this. So it has taken a deviation of 180 degrees, which is maximum. Next case, delta is minimum when angle of incidence is equal to 90 degrees. That is when incident ray is grazing the mirror surface. Then let us see this. This is mirror M dash is the mirror. See here, incident ray is grazing like this, and this is normal. Then what is angle I? Angle I is equal to 90 degrees. Angle R is equal to 90 degrees. Then what will be delta? Delta is equal to same. Angle R is going like this. So delta will be 0, which is minimum. So in these two cases, first case when delta is maximum when incident angle I is equal to 0. So when incident ray is falling at 0 degrees angle with the normal, then I is equal to 0, then R is also 0, then delta is 180 degrees, then delta is minimum. Here delta is maximum here, delta is minimum when incident angle is 90 degrees, then delta is equal to 0 degrees, which is minimum. You note these 2 points. Pause the video and note the 2 points. Okay. Next, here we have to consider another case, that it is when an incident ray is suffering multiple reflections, then angle of deviation is the sum of algebraic sum of each angle of deviation. That is nothing but, suppose you observe this case. This is a mirror. M dash is a mirror, plane mirror. M dash and M double dash is another plane mirror. Both are arranged making 90 degrees angle. The angle between the two mirrors is 90 degrees. Then incident ray is falling on the first mirror, M dash, M double dash, like this, and it is reflected like this. Then after the reflection, what will be the emergent ray angle? It is anti-parallel to the incident ray. It is always anti-parallel. This is incident ray, this is emergent ray. So emergent ray is always anti-parallel to the incident ray when two mirrors are arranged perpendicular to each other. Here, what is the deviation? Observe this. This is the incident ray, it has to go like this. But it has taken some deviation, 90 degrees. This is 90 degrees deviation. Again, for second mirror, M dash, this will be the incident ray. It has to go like this. And again, it has taken a deviation like this. Again, this is also 90 degrees. Then what is the sum of angle of deviation total? Delta net. That is, total deviation is equal to, suppose this is delta 1, this is delta 2, this is delta 2, then delta net is equal to delta 1 plus delta 2. That is equal to 90 plus 90. That is equal to 180 degrees, which is anti-parallel. So observe this. When two plane mirrors are arranged perpendicular to each other, emergent ray is always anti-parallel to the incident ray. You note this one also. Okay, now look at this case. OM and OM dash are two mirrors, two plane mirrors arranged making an angle theta, any angle. So here incident ray is falling on first mirror OM dash, incident at a point, let it be A is the point, and this incident ray which has fallen on OM dash mirror is reflected towards second mirror OM. At this reflected ray is incident on the second mirror at a point B. Okay, next, again this second incident ray to the mirror OM is reflected and it has gone away. In this case, what is the total deviation? Here we have to observe one thing. The total deviation does not depend on the incident angle of first incident ray or second incident ray. It depends upon the angle that is arranged in between the two mirrors. That is the thing. Irrespective of any incident angle, if this total deviation is same. It depends upon only the angle between the two mirrors. That it depends upon theta only, neither on the first incident angle or the second incident angle. Here, let us observe this. Let us see, for this is IR1, incident ray 1. This is incident ray 2. Okay? For IR1, for incident ray 1, that is falling on first mirror OM dash, angle of incidence B alpha. Then angle of reflection will also be alpha, because angle I is equal to angle R, implies angle of reflection is also alpha. Next, let us see second case. For IR2, incident ray 2, that is actually this IR2 is a reflected ray of first mirror. This becomes the incident ray for second mirror. For IR2, angle of incidence B beta, then implies angle of reflection is also beta. For IR1, what is the deviation? Let this incident ray has to go like this. It has to go like this. But it has deviated. Let this angle be delta 1. Let the first deviation, angle of first deviation, let us talk like that. Angle of first deviation B delta 1. Then what is the delta 1? Therefore, delta 1 is equal to, here it is delta 1. Then what is the value of delta 1? This is 90 minus alpha. This you know that delta 1 value 180 minus 2 alpha. 180 minus 2 alpha. We know that delta 1. Next, let the angle of second deviation be delta 2. Therefore, delta 2 is equal to 180 minus 2 beta. Okay. What is the net deviation? This is first deviation. Actually, it has to go like this. This is first deviation. Again, after the first deviation, the ray has to go like this. Again, it has taken second deviation. That is delta 2. So, net deviation. Therefore, delta net is equal to delta 1 plus delta 2. That is equal to 180 minus 2 alpha plus 180 minus 2 beta, which is equal to 360. 180 plus 180, 360 minus of 2 into alpha plus beta. This is number 1. So net deviation is 360 minus 2 into alpha plus beta. Okay, remember that. Now let us come to triangle AOB. This triangle. In triangle AOB, okay, let us see. What is this angle? Actually, this is mirror. This is normal to mirror. So this total angle is 90. So this angle OAB plus angle AOB plus angle OBA is equal to 180 degrees. We know that the sum of 3 angles in a triangle. Then what is angle OAB? OAB is 90 minus alpha. 90 minus alpha plus angle AOB. AOB is theta. Already we have taken the value. The angle between the two mirrors is theta. So angle AOB is theta plus angle OBA. OBA is nothing but this is normal N2. So that is 90 minus beta. Now what you got? 90 plus 90, 180. Okay, 180 plus theta minus of alpha plus beta. Alpha plus beta is equal to 180. So let us cancel 180, 180. Finally, what we got? I will write here. From that equation, theta is equal to alpha plus beta. This is number 2. Number 1, observe this. Net deviation is equal to 360 minus 2 into alpha plus beta. Now, put equation 2 in 1. What you got? Delta net is equal to 360 minus 2 into alpha plus beta is equal to theta, 2 theta. So 360 minus 2 theta is the value of net deviation. Observe here. When two mirrors are arranged making an angle of theta here like this, the net deviation does not depend on first incident angle, either the first incident angle or the second incident angle. it entirely depends upon the angle between the two mirrors, that is theta. So observe this, delta net is equal to 360 minus 2 theta. Just note this, pause the video and note.